Now in the previous video we have discussed some about methods and attributes, objects inside of the object-oriented programming. Now today we are going to move one more step ahead. Today we are going to talk about inheritance in object-oriented programming. What is inheritance? And the kind of inheritance there are. Then we will discuss some practical examples based on it. So the question arises, what is inheritance? Now let's talk in a layman term. You use the word inheritance. It's just an English normal word. Inheritance means taking someone else's properties. Like you say, I inherited these kinds of qualities from my father, or you say I inherited what my father owns. Right? My father owned a big house. I inherited that house. Not this house is my. Not this house is mine. Okay. This is called inheritance. Okay. Same way it works in the class also. There is this one class and there is this another class which inherits the properties of the previous class. Now this is inheritance. This is just a simple English meaning, and this meaning is actually the meaning that will be used inside our OOP. Now there are three kinds of inheritance. If you see in the real life, there are three kinds of inheritance out there, even in the OOP also. Now these are single inheritance, like you inherited the properties of your father. Just this, only this, there is this much only relation, father and son, and you inherited the properties of what father have. Okay, what father owns becomes yours. Now this is single inheritance. Then there comes multi-level inheritance. Sorry. So in that what happens? Like what your grandfather owns becomes your father's. Then all of those things, what father owns and what he inherited from grandfather, become yours. So basically what you own now is what your grandfather owned and what your father owned. You have all those properties inside yourself now. Now this is called multi-level inheritance. Okay, it can be as long as the chain you can create. Then third one comes multiple inheritance. Now multiple inheritance is like you own the properties that of your father, what your father owns. Then at the same time you own the properties of your mother, what your mother owns. So now you have the properties of your father and mother, but at the same time none of the properties of father matches with the properties of mother. Means like father and mother are two different entities. They both are not inheriting anything from each other. Okay, they are different entities, and but you are inheriting the properties of both of them, father and the mother. Means you are creating two branches out of which are coming at you. Now this is called multiple inheritance. So let's see all of these examples in our spider. Okay, so here we are. Now let's create a class. Let's say class. Let's make it first. Okay. Now let's create some methods inside of it. Like let's say def meth one, and obviously self. Okay, and print something out of it. Print. mm, let's say meth one. Okay, just print meth one. Okay. Then let's create another function. Okay, wait. Let me zoom it out. You might not be able to see it properly. Okay. Def meth 2, and again self and print, and this time we're gonna print meth 2. Okay, so this is, we have created one class with a name first, and these are the two methods we have defined inside of the class. We have two properties we have defined inside of this class. Now let's create another class. Class second. Okay. Okay, what we did? Oh, we created a cell and run it. Sorry. Class second. Okay, now def, and let's create a method 3 over here with the name self. Okay, and let's print it meth 3. Now we'll give one more method over here, def meth, let's go 4 self, and again we are gonna print math underscore 4. Now we have created two class out here. Okay, so now what we talk about single inheritance. Single inheritance means was the properties of one class is inherited by the properties of another class. So there's this one class first and there's the second class. Okay, now if we create an object for the class second, let's say sec is equal to second. Okay, now we have created this object. Now let's see what are the functions inside, methods are inside of a sec. Now if we say sec, now we see there are two methods, math3 and math4. Okay, now we can call math underscore 3 and let's execute it all, and it prints math 3 over here, or we can print it at the same time. We can print either we can say 4 and let's run it, and it says math 4 print out. Okay, but what if we want to use this class and print the method of the first? What if we want to use the object of the second class but we want to print the method of the first class? This means the second class inherits the properties of the first class and use it. So nothing you have to do, just simple create a parenthesis over here and write first. Now let's run it. Let's run this much, F9. Okay, it runs perfectly fine. Now let's see how many class object sec has. Now you can see here object sec has 1, 2, 3, 4, all the 4 classes over here. Now if we say sec math underscore 1 and if we print it, now it is working just fine. Math 1 it printed out. We haven't created a class object for the first class. We were using the object of the second class and we were able to use the properties of the first class. Now this kind of thing can be used in, like, you are using some kind of a mathematical, geometrical calculations, and in that you defined one method area. Now you can create lots of class, like one class of rectangle, then one class of circle, one class of square, and use that only that method of the parent class method area, and by that method only you can calculate the area of all of those 3 different classes. I will show you now. I will show you an example, but I want you to work it on your own. Okay, see how you can work this thing out, how you can find the area. Okay, so this was single inheritance. Now, if we talk about multi-level inheritance, now let's create one more class over here. Now, to multiple level inheritance, we need one more class. So, class third. Okay, and again, let's define few functions or methods over here. Math 5 and print math 5. Then let's give one more function, math 6, and print it. Okay, so we have created 3 functions. Now what we want to do is I want third to inherit the properties. Okay, and why I remove this data. Okay, now I want third to inherit the properties of first and second. Okay, third is like a child, first is like a grandfather, second is a father, and third is a child. Now third wants to inherit the properties of first and second both. So now what we have to do is, all we have to do is write second over here. Okay, now what third has to do is, third has to just inherit the properties of the second. And what second has the properties? Second has properties of its own as well as of the first. Okay, what the properties that your father has are himself, the properties of himself, and as well as the properties of grandfather. Okay, so father contains both the properties, so you don't have to rush up to the grandfather. All you have to do is inherit whatever your father has, because he also has what your grandfather has. So the simple concept, you can use a family tree kind of thing and you can apply it over here. The same concept applies over here. Now what third did, it just inherits the properties of second. It says second, you already have the properties of the first, so I don't have to go to the first. I will inherit your properties and I will have everything. So now let's create an object for the third this time. Okay, now let's run it. Okay, it runs perfectly fine. All the three methods run fine. Now let's see how many methods this time THI has. Now you can see here it has 1, 2, 3, 4, 5, 6. All methods it not THI contains. Now we can use any method in the THI. We can use math1, math2, math3 or math4. Now this is multi-level inheritance. Now the third thing comes multi-level inheritance. Sorry, multiple inheritance. Now in multiple inheritance what happens is, let's remove this. There's no connection between first and the second right now. First is a separate class, second is another separate class. In what third does, it inherits the properties of the both. So all you have to do is write like this, first comma second. So what it will do is, no, it will inherit the properties of the both class. Again, if you write it here, okay, let's run it again. Okay, now if you again press start over here and you see again third has all the properties 2, 5, 4, 6, 1, 3. All of the properties again third can work on with. Now this is the basic inheritance we've talked about till now. Now what happens here? Let's say your father is very hardworking, okay, and you are also very hardworking. But what you are, you thought, I don't want to be that much hardworking. I want to be a little less hardworking, and at the same time, I want to be smart. Okay, not just hardworking. I want to be smart. So what I did, I just changed. I'm not accepting the hard working of my father. I'm accepting all of the properties, but I'm not accepting inheriting the property of my father, that is hard working. I'm using that property of my own. Okay, so let's say class second said, I don't want to use math1 function of first. I want to use my own math1 function. Okay, and it is inheriting from the first, and it says I don't want to use math1 of the first class. I want to use math1 of my own. Okay, now in these kind of situations, all you have to do is you have to create your own math1 function. So basically what happens is, when you create an object, sec equals to second, okay, you create this object, and when you try to run any method, call any method, sorry. So what it does, let's say math1. Okay, now when you call this method, it will first check in the second, okay, in the second class. It will see if math1 is present over here. If not, then it will go to the its parent class. If it is present in the second class, it will not go to the parent class. It will just run the method in the of the second class only, of the child class. But if it does not find the method over there, then only it will go to the parent class. So this property can be used over here, and it says I want to use my own hardworking quality, not of my father's. So what it says, let's run it again. Let's right now ignore the class third, we don't need it, and run the object. So here it printed for the math1, it printed math3. Now here in the second class, math1 was printing math3, right? So it run the math1 function of math3. Now this is the one of the properties of inheritance. You can manipulate like this. Okay, so now the another thing comes. Let's say now third comes here. Okay, what third was happening? Now again let's remove it. Now in this third set, um, third also wanted to use math1, but if we create a if we create object over here, third. Okay, let's give let it sec only. Now sec third class also want to use the math1, but tell me, if I'm gonna run this program, which math1 is gonna run? This math1 of first, or this math1 of the second? Which is gonna work if I run this program? Let's say, okay, let's first of all run all of this. Okay, F9, and if we run this last line calling math1, it runs on the first class, parent class, class first. Why it did? Now there is this concept of called um, a method order kind of thing, in which what happens is it works from left to right. Here we have called first function, and then we have given it second function. So what happens is it will, first of all, what it will do, it will check in the third. When we run this, call this method meth1, it will first check in the class third and see if it doesn't find in its own class, then it will go to the class that we defined first. We inherited first class first in the first position. So it will first go to this first class and it will check here. And if it doesn't find here, then only it will go to the class second. If it finds in the class first, it will just run that math one only and will print it out. Now, if we reverse order it, let's say second comma first, and if we run this whole program, it prints out math 3 because in the class second there is math 3 present. It checked in the class third, not present, then it goes to the next second class, which is second, and it finds it over there, it printed it out. This is another property of inheritance. Then okay, so now let's understand this whole concept that we have studied right now, that we worked on right now, inheritance. Let's see it out with one example that I have prepared. Okay, see, this is example that I was talking about earlier of one class rectangle which contains area and a parameter as two methods and one init method, and then there's a square which contains this init method, and this I will explain what this is, whole is, and then we are gonna call square. And you see there's no square dot there's no area method over here, but still it is, I will run square area method on the square and parameter method in the square. So let's see what I've done over here. I've created this one class here, class rectangle, and then I created one constructor over here, init. Yeah, init method, or you can call it init, is also called as a constructor, dash underscore underscore init. Now in this I've called two attributes or parameters, you can say length and breadth, and as we have learned earlier, we have given them in a variable self.length, self.breadth, because we want to run it further in the further in the class. Then we created one method area, def area, and this we have printed out the self.length into self.breadth. Means whatever the values we are gonna get in the length into length and breadth, we are gonna multiply it, and that's the formula of an area, right? Then we've created a one method for the parameter, and to find the parameter of a rectangle, what we have to do is 2 into length plus breadth. This is the formula of the parameter, and this is the class. These two methods, these two properties of a rectangle, area and parameter. But what then again next thing comes is the class is square. Now what square is? Square is also a kind of a rectangle, but with all the sides equal. So now the finding the area of a square and rectangle is same. You have to multiply both the sides. And perimeter you have to add both sides and multiply by 2. The concept is all same. It's just in the square the values are same, in rectangle the values are different of the sides. So what we did, we decided let's not create area and perimeter function of a square. Let's inherit those functions from the rectangle. So what we did here is we inherit rectangle inside of the square function, inside of the square class. Then we again created this constructor. Here we in def init self comma side as a perimeter which is accepting one value when we are creating this object. So what basically happening over here is we created this object over here, sq.square. Okay, we created this object over here, sq.square 5, and we have passed this value 5 as on one side of it. Okay, we have passed this value over here. Now I haven't told you like earlier about this concept. Now what this concept is, this is called using when normally what happens, if we come here back. Now if we have created our own math function in the class second, then it will not go for the math one of the class first. Okay, it will find math one first in the class second, and if it finds it over there, it will run it over there. It will not go to the math one of the class first. Same thing is here. I have created my own def init over here with saying self side. If I would not have, let's say I put a, I make it a comment over here and give it a pass. You know what pass does? Okay. And if I would have passed two values over here, 5 comma 5, as square says both the sides same. And if we run this program, okay, worked perfectly fine. Now let's find this area of the square. Okay, as you can see here, class square has nothing inside of it. It is empty, completely empty. Even we have given it a pass over here. Now if we run square over here, now you see in the output screen it is printing the square. It is giving it value 25 over here in the output screen. 5 into 5, 25 is the area. Okay, if we run sq.perimeter, giving it 20, 5 into 4, 20. That's the perimeter of the square. So this is like we are giving it two values, and class square is, as class square is inheriting area and perimeter of rectangle, and it is working just fine. But why are we giving two values and both the values are same? Why are we passing two values? Why not pass only one value? Because there is, because when create finding a area of a square, we say a length square or side is square. We don't say length into breadth. Basically, generally we give it one, we pass only one value. So if we pass one value, but what happening is here is this here init function is accepting two values. Okay, and we are passing one value, it will give us an error. Let's see, and it says missing one required positional argument, breadth, because 5 is going to the length, self is getting the sq, but what breadth is getting? Nothing. Breadth is empty, so it is giving us the error. So what we did is we created our own init function over here. Okay, now this init function is accepting only one value. Then what we did, now we have nothing over here, we don't want to work over here, we want to go back to this init. Okay, because here we are defining these variables and passing the values inside of it. So now at this time this super function comes in the role, and what it does, it it calls the method of the parent class. Also it calls the constructor of the any methods of the parent class as well. So what super does, it calls the methods of the parent class or the class which is being inherited, and as you see I have used super, then dot, and I have called this method init over here and give it two arguments, side comma side. Now at this time you don't have to give it self, because self is already understood over there. You don't have to pass it, all you have to do is pass to these parameters, side comma side. Now the side we have given 5, we have passed 5 to this side in the square, and that side is passed here in the inherited method over here, super. And then now there are two position arguments, these, and there are two position arguments here accepting them. So now if we run it, okay, let's move past now, there's no need of it. Now if we run it, now you see it works perfectly fine. It gives us the area, it gives us the perimeter, and we are only passing the one value. This is how inheritance works. Yeah, you can see this is a simple single inheritance concept. We can also apply multiple inheritance by using create some other function, some other class like circle, cube, cuboid, create find the volume of it, find the parameter of it, use the same methods, or do some kind of a create some kind of a different method. Now this is all that we work, that is an inheritance. Now okay, let me explain one more thing. Okay, we have seen here, we've talked about this second comma first thing, right? The method order, method resolution order, MOR, sorry, MRO. Now let's practical this over in our here in this program. Okay, so just let's simplify it. Let's create one more class over here, and let's say class and circle. Okay, and okay, not inheriting anything, and create one init function. not accepting any value. As I'm creating it's very simple of it. Okay, and let's say circle in it. Okay, it will print circle in it inside of it. And what this is doing is this is inheriting the values of both rectangle as well as circle. Now let's print something over here too. Print rectangle in it. Okay. Now what here happening is here is I've created one more class over here, class circle, and created one constructor inside of it in it and printed it circle in it. Okay. Now let's see what this super is going to do. What it is going to run. Okay. Let's make it more simple. You know, let's do it hash wait comment and remove it all. Okay, wait a minute. We have to do a lot more editing than that. Okay, let's say let it pass the values and let's accept it over here as radius. Okay, circle has got radius inside of it, right? Yeah, but it is passing two values, accepting only one. Let's create it also radius. Let's say radius now underscore 1, as both the values will be same, so it won't affect much. I'm just telling you this just to give you an example idea of it. Okay, how it is really gonna work. And we are printing it something over here, we are printing something over here. Now let's see. F9 works perfectly fine. Now let's create a okay, we need square only. F9, and you see, as I run this constructor initiated. Now what it did, it went to the square and it see def init self comma site. So now site got the value 5, and then it went to the super function, the super method over here. And in super method we have defined circle first, we've called circle first, and then we have inherited the rectangle. So what it did, it went to the circle first. In circle it says it has given the value side to the radius and another side to the radius 1 and printed circle in it over here, and that's what it does. And it did not bother to go to the rectangle and did not worked on this constructor of the rectangle. And if at the same time if we would have reversed the values, rectangle comma circle, and if we would have worked, now this time it printed rectangle in it, because at first rectangle was inherited, so it went directly to the rectangle and it printed it. And if we print something over here, let's say print square in it, and if we run it this time, it first goes to the rectangle in it, it runs in the rectangle, and then after the super method is called, is done, then it comes back to the print and it printed a square in it. So this is all about inheritance. We have covered all the three kind of inheritance, then we have seen them in the this is our example over here which I've created for you. So now, this is just a basic example, very basic example. Now you applied in your practical way in which some kind of problem solving. You applied these examples, and see what else you can achieve from this inheritance concept. More you can do is you can there are like lots of competition websites. You can go over there, you can participate in those competitions. You can see what kind of questions there are. You can try to solve those problems, solve those questions, and it will help you a lot. It will help you a lot in practicing Python programming, because Python is all about any programming language is all about practicing. The more and more practice, more and more you do practice, the more you get it better. Okay, so see you in next video.